Welcome to qnawire.
Okay, so I see that you need help with this question. I am using Excel to organize my data and to help draw the scatter diagram. I'm assuming if you're doing this type of a problem that you do have some type of a program like Excel. If you do, then you can follow along. If you don't, you can use graph paper, paper pencil, scientific calculator. Just might take you a little bit, but you should be able to follow along because I will be giving you step-by-step directions. So it says, do heavier cars really use more gasoline? Suppose a car is chosen at random. Let X be the weight of the car in hundreds of pounds and let Y be miles per gallon, mpg. So we have our X and Y set up here. Draw a scatter diagram displaying the data. So I'm going to insert my scatter diagram. And here's my scatter diagram. And I'm going to make sure that I have titles. So my X is my weight of the car. And that is in hundreds of pounds, and my Y is in miles per gallon, and that is in mpg. Okay, and this here, my title of my chart is going to be cars and weight of cars and gas. Weight of cars and gas. Okay. And so that is actually, let's see. All right. And so then verify the given sums. So here's the given sums. So the mean of X, the sum of X is 294. The sum of Y is 163, and we do not have to go out that many spaces. Okay. Then the sum of the squares of X, let's see if that is that. So I have to find the distance first between X, each one of the X values, and the mean of X. First. Oh, actually, no. So that is the sum of the X value, but then I have to find the mean of my X value. Okay, so then I'm going to take so that is the sum of the X, and then my mean of my X. Oops. Come on, equals mean of X is going to be that. And that is going to be, so I need to highlight and bold these. Okay, so I'm going to take each one of these values, the X values, and I'm going to subtract 36.75. Okay. And then I'm going to take each one of these Y values and I'm going to subtract 20.375. And let me center these all. And then I am going to multiply this value times this value. And then this times this, and then this times this, and then so on and so forth. And then I'm going to total up all of those values. And the sum of my products is going to be, this. And then my X squared is going, so this is not accurate because the sum of my X times my Y's is not, so I'm going to put this in red. So that's not accurate. This is correct, so I'll put this in green. This is correct, that's in green. And we haven't found that, the sum of my x squared. So then this squared, and then I'm going to square each one of these values, my x minus the mean of x values. And then I'm going to total them. And that is not correct. Oops. So that is not correct. Let me see if this is correct now. And then let me total that. $287. Nope. That is not correct either. And then let me calculate my correlation coefficient. So to get my correlation coefficient, you're going to take the sum of the products and you're going to divide it by the square root of the sum of the squares of x. So hold on, square root of the sum of the squares of x times the sum of the squares of y. And that is correct. So I'll put that in green. Okay. So then we are going to find the value of the coefficient determination, so r squared. What percentage of variation in y can be explained by corresponding the variation in x, the least squares line? What percentage is unexplained? Round your answer for r squared to 4 decimal places. So r squared is going to equal, so r squared is equals this number squared. That's it. Okay, so that is to 4 decimal places equals 0.9010. And I will highlight that. See if it will let me highlight it. Oh, I'll put it in red. Okay, suppose a car weighs x equals 39. What is your least squares line forecast for? So that is if x equals 39, okay? So my least squares line, my regression line would be, so my slope is going to be sum of my products divided by the sum of the squares of x. And so I'm going to highlight that and bold it and merge it. So that's going to equal the sum of the products divided by the sum of the squares of x. Then my y-intercept is going to be the mean of y minus my slope times my mean of x. So I am going to highlight, bold, merge. So that is going to be the mean of y minus my slope times the mean of x. Okay, so then I'm going to bold it, highlight it. Highlight, bold. Okay, so then my linear regression equation is going to be y equals negative 0.571 x plus 330.881. And then that's going to be highlighted in bold. So if x equals 39, then equals, and then in parentheses, negative 0.571 times 39, oops, plus, oops, plus 330.881. So for a car that weighs 3,900 pounds, it will be hold on, negative times 30 plus 330 minus the slope. So mean of y minus the slope times the mean of x. Let me do that again. So I have equals the mean of y minus the slope times the mean of x. Oh, because it's starting at 330. Okay, so it's 39. Oh, okay, I know why. Equals the mean of y minus the slope, parentheses, minus the slope times the mean of x. Haha. It's really, that's why I like to merge this. This should say, I knew something was up, 41.36. Oops, 41.36. Okay, so equals negative 0.571 times 39, and I should put that in parentheses, and then plus 41.36. There we go. Will be 19.09 pounds mpg. So I hope that this video helps. This is the middle school math teacher signing out.